Good morning, students. Today we are going to briefly discuss about another part of sound. So let's start our video. On first day we have discussed some basic idea of amplitude, frequencies and time period. Today we will briefly discuss about amplitude and time period and frequency of sound. Before that we have to know what is actually vibration is. So I think you have all seen swing in a park. So for swing, if this is swing, the upper portion of the swing is always fixed and the lower portion of the swing is movable. So when you displace the swing and release it, then what will happen? It will move back and forth direction. This type of motion is called oscillation. This type of motion is called oscillation, or it is also called vibration. Basically, the back and forth motion of a moving object is called vibration or oscillation. Now there are some characteristics of vibration. So what is amplitude? Before that, we have to know what is pendulum. Pendulum is a apparatus which consists of a thread where one point is fixed and the other point is tied with a metallic ball. This thread, this is a thread, and one point of the thread is totally fixed and the other point of the thread is tied with a metallic ball. Now, this is the position of rest. This is the position of rest. Suppose it is O. Now we displaced its position into this position. If we release, then what will happen? The bob is going to the right direction and again it will back to the previous position and it will continues. This motion is also a vibrational motion. This motion is also a vibrational motion. If this position is O and it is A, suppose this position is A, this position is O and this position is B. Now the maximum distance the bob is going from the rest position or central position is called amplitude. Basically, AO is the amplitude and AO is equal to OB. AO is equal to OB. So AO and OB is the amplitude for this motion. Now we talk about time period. So complete one oscillation, the time taken by the vibrational object is called time period. Suppose it starts moving from this position. So first it goes there and again it goes back to there and again it goes back there. So this is the complete oscillation from the starting position back to the starting position and again go to the other side and back to the starting position. This is a complete oscillation. So the time taken for one complete oscillation is called time period. Okay. Now we talk about frequency. Now we talk about frequency. What is frequency? In the number of oscillation in 1 second, the number of oscillation in 1 second is called frequency. Suppose it oscillates. Suppose it oscillates almost 30 times in a second. 30 times in a second. Then the frequency will be 30 Hz. Hertz is the unit of frequency. Now there are some relations between time period and frequency. Basically, frequency is equal to 1 by time period. This is the relation between frequency and time period. So what is the relation? The relation is frequency is equal to 1 by time period. Now I give you an example. If this this pendulum oscillates 30 times 30 times in 5 seconds, that then it may take 30 by 5 in 1 second. In 1 second it will oscillate 30 by 5 times, that is 6. So this is the frequency. So the frequency is 6 Hz. The frequency is 6 Hz. Okay. Now what is the time period? So the time period is 1 by frequency. So that is 1 by 6 second. The unit of time period is second. So the answer is time period is 1 by 6 second and frequency is 6 Hz. This is how we calculate the frequency and the time period. Now what is the conclusion from this? What is amplitude? Amplitude is the maximum distance, that means this distance, either AO or OB. AO is the maximum distance from its rest position. So the maximum distance from its rest position of a vibrational object is called amplitude. What is the time period? Time period is mm, the time taken by the vibrational object. The time taken by the vibrational object for complete one oscillation is called time period. And what is frequency? The number of oscillation takes in 1 second is called the number of oscillation takes in 1 second is called frequency. And frequency frequency is inversely proportional to the time period. And another thing, the unit of frequency is Hertz and the unit of time period is second.
Actually, frequency depends on the length also. If for pendulum, if we increase the length, the frequency decreases, and if we decrease the length of the pendulum, I mean of the thread, then the frequency increases.
Now we talk about loudness. Actually, loudness it depends on the amplitude. Loudness is depends on the amplitude. When the amplitude is increases, the loudness is also increases, and when the amplitude decreases, the loudness is also decreases. We can say, or actually, loudness is proportional to the square of amplitude. Loudness directly proportional to the square of amplitude. That means when the amplitude increases by 2 times, the loudness increases by 4 times. And when the amplitude decreases by 1 by, I mean half times, that means the loudness decreases by 1 by 4 times. So this is the relation between loudness and amplitude. Now what was the unit of loudness? Actually, the unit of loudness is decibel. The short form of decibel is D capital B. For normal conversation, the value of loudness is about 60 decibel. In the traffic, the value of loudness is about 80 decibel. So up to 80 decibel, the sound is may hurt your ears, and beyond 140 decibel, it actually painful for us. It can damage your ear. Now we talk about pitches. Pitches actually depends on the frequency. We know what is frequency. Frequency is the number of oscillation in 1 second. So pitch is depends on it. Actually, pitch proportional to the frequency. When frequency increases, the pitch also increases, and when the frequency decreases, the pitch is also decreases. Basically, uh, what there are two types of frequency. One is low frequency and one is high frequency. Now, what is low frequency? Low frequency, this is the picture of a low frequency. This is the waveform actually. This is the waveform of a low frequency, and this is the waveform of an high of a high frequency. So what are the difference between them? Uh, Actually, the distance between the two peaks, you can see the distance between the two peaks in low frequency is greater than the distance between the two peaks in high frequency. High frequency waves are very near to each other. So if the frequency is low, then the pitch is also low, and if the frequency is high, then the pitch is also high. The low frequency is an example of men's voice. Men's voice frequency is low, and the women's and the children's voice, the pitch of their voice is high. So this is the men's voice frequency, and this is the women's voice frequency or children's voice frequency.
Now we talk about audible sound and inaudible sound. If a vibrating object is vibrating three times in a second, we cannot hear. So to hear some sound, the object should vibrate at least 20 times in a second. At least 20 times in a second. And the highest range is 20,000.
So if some object is vibrating from 20 times to 20,000 times, we can hear it. So this is the range of audible sound. That means we can hear, human beings can hear the sound if some vibrating object is oscillating 20 to 20,000 times in a second.
So it is 20 hertz. 20 hertz means 20 times vibrating in a second. And this is 20,000. 20,000 hertz. That means 20,000 times vibrating in a second. Now, if some object is below this range, suppose 0 to 20, then it is called infrasonic. Infrasonic. And beyond 20,000 hertz, it is called ultrasonic range. Not only, there are some animals who can hear the ultrasonic waves. Ultrasonic means beyond 20k hertz, that is maybe 40 kilohertz. They can hear high frequency sound like 40 kilohertz or 70 kilohertz, etc. So bat is an animal who can hear, not only hear ultrasonic sound, they can produce also ultrasonic sound for screaming. Like bat, dogs and deer and many other animals can hear ultrasonic sound, but bat can produce also ultrasonic sound as well as the hearing. I already explained what is noise and what are the types of musical instrument, and what types of sound are producing from different types of musical instrument. So please go through this video. I think this was the first video. So please go through this for noise and etc. And that's it for today. From tomorrow, I will provide the short type answer questions. And thank you.